So right here we have a piece of ice. You can see the little water molecules. The orange bits are oxygen, and the two white bits on each one, that's the hydrogen. So we have water here. This is a solid. This is a little tiny piece of ice. The little particles aren't perfectly still because they still move even when they're locked up in ice. Now if we add heat, watch what's happening. Those particles gain just a little bit of energy, and now they can move against each other. All right, so this water is just jiggling around. Most of this down here at the bottom of the container is just a big drop of water. You can see, oh, there was one piece that evaporated out. But if we add more heat, you'll see more evaporate until the whole container is just full of a gas. So we're adding heat pretty quickly now. Is much of it stuck together, or is it all apart? Obviously, yes, it's all flying around. This is a gas. So if we start taking heat away from this system here, if we start taking heat away from those water molecules, you'll see them go from a gas back to a liquid. So here they are, clumping back up. This is called condensation. Okay, I went too far. Okay, so they condensed back into a water. Now watch what happens if you take heat away from the water. Now we're back to a solid. Okay, here we go with the notes for lesson 1, the states of matter. So like we just saw in that little simulation, the solids, the atoms are locked together, but they're still moving. They're moving more slowly than the other ones. And all solids have a definite shape and a definite volume. That means it doesn't matter if you put an ice cube in a glass or in a bowl or on a plate. It's going to have the same shape, that same definite shape, and it's going to have the same volume, take up the same amount of space. Okay? So the second part of this then is liquids. Liquids, the atoms are not locked together. They are clumped together but moving freely. And we'll look at a video here that showed the element mercury. Now this is a liquid metal. It's liquid at room temperature. And this is a sponge that's inside of that metal. Okay. Those atoms are clumped together, but they're moving freely. So liquids are, just like water. They can move around. Now, liquids, they do not have a definite shape. They'll fill up the bottom of a cup or a plate, but no definite shape. However, it doesn't matter where they are, they can have the same volume. So that is a liquid. Now, gases, on the other hand, these atoms are bouncing around and moving freely, like we saw in that before. Gases, they're bouncing all over the place. They have no definite shape and no definite volume. Okay, so we're going to move on and draw some pictures that go along with these. Now, solids are first. Solids make up basically, here's a cube. Let's call it a sugar cube, okay, or an ice cube. There's a bunch of atoms in a cube. Definite shape, definite volume, solid. Liquids, on the other hand, they kind of flow to the bottom. Okay, so this is a liquid at the bottom of the container. Gases, on the other hand, are flying, zinging all over the place, bouncing into each other. Okay. I put the arrows here to show that they're moving very quickly. So you might want to pause this to draw this. We're going to move on. So how temperature and phases of matter affect each other. Okay. So on the solid side, we have a lower temperature. On the gas side, we have a higher temperature. So no matter what material it is, it's a solid when it's a lower temperature, and then if you get it hot enough, it'll turn into a gas. Okay, moving from left to right, increasing temperature. All you need is an arrow here showing the relationship that increasing temperature as you move this way. Okay. So there's a few terms that I definitely want you to know. Okay, first two are condensation and freezing. Condensation happens on windows, on cold drinks whenever you see water collecting somewhere. Condensation is moving from a gas into a liquid phase. Where the water wasn't a gas, now it's on the outside of your can of pop, so now it's a liquid. Freezing is moving from a liquid to a solid. You should know what evaporation is. For my class, we're going to use it a lot. Evaporation is when a liquid turns into a gas, and then melting is a solid turning into a liquid. So hopefully you're familiar with these. We're not going to spend a lot of time on it, but there's a few bonus words that I'd like you to know. Okay? So one word is sublimation. Okay? You can see down here in this diagram, if you have something like dry ice, goes straight from solid to gas, it sublimates from a solid into a gas. Okay. This is what happens to frost on your car most of the time. It doesn't melt, it just evaporates or sublimates right into the air. It goes from a solid to a gas. And then frost is the opposite. When you have a gas going straight to a solid, it usually happens on a cold night. This is a little diagram video of dry ice sublimating. Dry ice is just solid carbon dioxide going from a solid back into a gas. Okay, this last one I'll show you. What this is, wait for it to reset, this is molten salt, very, very, very hot, going into a fish tank. That water evaporates so quickly, it flash boils so quickly, it basically explodes, which I think is pretty cool. One more time. All right, that's it for the notes. Let me know if you have any questions.